Okay, so this is the video that'll take us through some of the vocabulary words in the 12-4 notes, and then also some of the theorems. And then the rest y'all are going to do as part of one of your assignments that's due Monday. So, if you turn to the page that starts with right angle, and then about halfway down, we have the word vertical, or the term vertical angles. So we're going to start with this word, and these are the words that we're going to need to know to complete a particular activity on Monday. So that's why I wanted to take the time to go over these in a video rather than just having y'all copy them. So starting with vertical angles, I think it's easier to kind of look at what they are, and then I'll write down, excuse me, a more formal definition. So if we have two lines that are intersecting, right, so I'm just going to draw it off to the side. The vertical angles are going to be the ones that are non-adjacent, so they're not next to each other. So in this picture, like if we called this angle 1 and this angle 2, these are vertical angles. And what's cool about these is that they always have the same measure. Vertical angles always have the same measure. So to kind of formally write it out, vertical angles are non-adjacent angles formed by two lines that are intersecting. And we said they always have the same measure. Next, talking about supplementary angles. Two angles are considered supplementary if the sum of their measure adds up to 180 degrees. So two angles the sum of whose measure is 180 degrees. So if we wanted an example of those, I'm going to switch colors. Let's say we had something that looked like this. And we'll look at this angle, I'll call it angle 1 and angle 2. And I know that these are supplementary because we have this straight angle right here, right? And a straight angle, its measure is 180 degrees. So since angle 1 and angle 2 combine to form that straight angle, we know that they're supplementary because they're adding up to 180 degrees. Moving on to transversal. Let's say we have two lines. I'm going to call them N and M. And let's say that these lines are intersected by a third line. We'll call it T. This third line is the transversal. So we call T the transversal. So for example, let's say that's line N, line M, and then here's T. Right, T is intersecting both of those, so T is the transversal. And then with that, keeping that picture in mind, I'm going to switch colors again. Corresponding angles, so I think again it's easier to kind of start with an example. So like if we're looking at, say, angle 1 right here, that's the angle that's in the same position relative to t is the corresponding angle. So like in this case, angle 2, right, is in the same position relative to t, just on line m instead of line n. So angles 1 and 2 are corresponding angles. So the example, angle 1 and angle 2, right, in that picture off to the right. And so we say they're corresponding angles if they are in the same locations relative to the transversal. And it's worth mentioning that, so in this case, when I drew lines N and M in this picture, they weren't parallel. Like if we extended N and M, eventually they would intersect. But if you do have that N and M are parallel, then the corresponding angles are equal. They have the same measure. And so we'll actually talk about that as one of our properties. But before we get there, we have one more vocab word that we're going to go over, which is the alternate interior angles on the next page. So again, I'm going to set up, we'll switch to green, call this line N. Here's line M. Draw a transversal, call it line T. So if we look at, I'm going to call this angle 1 again, and this one is angle 2. We call these alternate interior angles. They're the non-adjacent angles that are formed by lines N, M, and T. And what's special about them in particular is that the union of their interiors, right? So like here's the interior of 2, here's their interior of 1. The union of their interior contains the region between the two lines N and M. Right, so if you kind of combined those regions, it takes up the space between these two lines. So these are called alternate interior angles, and we'll actually write that definition down. So again, in this example, I'll go back to green. The example that we had was angles 1 and angle 2 in that picture. But they're the non-adjacent, so they're not next to each other. Non-adjacent angles formed by N, M, and our transversal T. The union I'm going to erase that T just so I can write the word. The union of whose interiors contains the region between N and M. So again, these will come in handy in an activity that we're going to work on Monday. But now we're going to move on to some properties and theorems. So we'll start with the corresponding angles property. So we defined corresponding angles above. And so this is that special property that I was talking about, where if we have two parallel lines, N, well in this case they're calling them L and M. If you have two parallel lines, L and M, and then you have a transversal, so here's L, here's M, right? So let's say that these are parallel. And then we have our third line, the transversal, we'll call it T. Then any set of corresponding angles, so if we were looking at these two, right, these would have the same measure. Since L and M are parallel, we could look at these two set of corresponding angles. They would have the same measure since L and M are parallel and their corresponding angles. We'd also have these two. Are corresponding, and then I'll find another color. These two would be congruent, meaning they have the same measure because L and M are parallel. And what's special, or what's something in particular that I want to point out about this theorem is the phrase "if and only if," and that's actually a very particular phrase in math. And what it tells us is that the property is true both ways. So, kind of going down here, I said it goes both ways, and you might be asking, well, what does that mean? That's kind of vague. That's a fair point. So, what it means is, if you know that L and M are parallel, then you also know that the corresponding angles are congruent. But it also goes the other way, where if you know that the corresponding angles are congruent, then it must be true that the lines L and M were parallel. So that's what that if and only if means. It goes both ways. And you'll actually see that quite a bit in math. Moving on to this next theorem. Again, we have that if and only if going on. So if we have, or if we know, right, that we have two parallel lines, again, we're going to call them L and M. So these are parallel if and only if, here's T, the alternate interior angles, so again, right, here's one set, they would be parallel if and only if the alternate interior angles were congruent. So we have two sets of alternate interior angles that I've tried to color code. So again, that's that if and only if. So if they're parallel, then we know the alternate interior angles are congruent. And if the alternate interior angles are congruent, then we know that L and M must have been parallel. The last theorem is talking about the sum of the measure of the angles in a triangle. And the theorem just states that it's 180 degrees. There is a proof in the book. If you want, you can copy it down. But I am going to skip it for today. If you're super interested and would like to know, I'd be more than happy to write it out. Just shoot me an email and I can do that. But otherwise, you can skip this. Don't feel the need to fill that in your notes. Just know that if you have a triangle, this isn't the proof, right? But if you have a triangle, here's angle 1, here's angle 2, and angle 3, then it must be that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So that's what I want you to take away from this theorem. But otherwise, the rest of these notes are for you to fill in as part of one of your assignments for Monday. I hope this was helpful. If you have any questions, feel free to email me, and I would be happy to get back to you. And we can also talk about and check in on these on Monday. But otherwise, thanks for listening, and have a good weekend.